In this class, we will discuss another topic of statistics, correlation and correlation coefficient. So first we will see what we mean by correlation. Suppose you have two variables x and y with some random values or discrete values, something like this. So here both x and y, so there are some random values, discrete values given. So the number of observations is taken as n. N is the number of sets of data observations. So sometimes you may be asked to find a relationship between these two variables, we can say. So that means we can say that this correlation is nothing but the covariation of two variables. And this covariation can be expressed in terms of a number which is called as correlation coefficient. Correlation coefficient denoted by R. R, small r. So here, this correlation coefficient is also called as Pearson's correlation coefficient. So in a given problem, so this set of values of x and y will be given. You may be asked to find the correlation coefficient for the given set of data. Now here, to find this value of r, we need to calculate two things. X bar and y bar we have to calculate. X bar is the average or the mean of x values, given x values. Y bar is the average or mean of y values. And once you get these things, x bar and y bar, we are defining the two terms. One is x minus x bar, another one is y minus y bar as capital X and capital Y. So here x bar and y bar, they are constants, mean values, whereas x and y are these values. So you will get another set of data x and y. So after finding this, we can calculate this rank correlation or this correlation coefficient using the formula sigma xy divided by sigma capital X into capital Y divided by sigma x square into sigma y square. So this is how we can calculate the correlation coefficient. One thing is important. So this R value will be in between minus 1 and plus 1. So the minimum value of R is minus 1 and the maximum value is plus 1. So the value of R lies between minus 1 to plus 1. The negative sign indicates that if R is negative, it indicates that negative correlation. Negative correlation means if x increases, y decreases. If x increases, y decreases, and vice versa. That means if x decreases, y increases. That is significant. If R is positive, then it means positive correlation. Positive correlation means as x increases, y also increases. As x increases, y also will increase. This is called as positive correlation. If R is 0, there is no correlation at all. No correlation. So this is the basic thing you should know. So these two x and y, they are not at all correlated. That is it. Some of the examples for this correlation, practical examples I can give. Marks of individual students in two subjects. Marks of individual students in two subjects. So because we are comparing the values in two sets. or you can take marks of individual students in tests, that is internal tests and in final exam. This also you can call it. Then the second example is you can take height and weight of individuals. Height and weight of individuals. For height normally it will be in centimeters. The weight will be in kgs. So these two can be correlated. For some 10 students, if they give the height and weight, we can always develop the correlation coefficient, how best they are correlated. That is the meaning. And some more examples we can give. Suppose if you are investing money in advertising and the profit obtained. So if you take the amount invested as X, profit obtained as Y. So sometimes amount invested may be more, profit obtained may be less, or sometimes it may be more, this is also more. So we can always find out the value of R. As I already told, if R is positive, as X increases, Y also will increase. That is the meaning. If there is some other way, if investment is more, profit is less, then it is negatively correlated. If they are not at all related in any way, then it is called as no correlation when R is equal to 0. So this formula we have to remember to calculate the Pearson's correlation coefficient. So in the examination they may give a set of data X and Y, and they may ask you to compute the value of R for the given set of data. Now we will take up a problem to find this correlation coefficient for a given set of data. So X and Y will be given. You have to find out X bar and Y bar. So then X minus X bar and Y minus Y bar we have to write down. They are capital X and capital Y. And using the formula which I have given, so you can always find out the value of the correlation coefficient R. Now let me take a problem. So the set of data is given like this. So let us take the set of data. So determine the coefficient of correlation or correlation coefficient, Pearson's correlation coefficient for the data given. For the following, okay? X and Y values are given. X, Y. So let us see how many set of data we are given. So X may 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. These are X values. Corresponding Y values are given as 9, 8, 10, 12. 9, 8, 10, 12, 11, 13, 14. So for this set of data, we need to find out the value of R. To find out the value of R, the formula is R is equal to sigma X into Y, capital X into Y divided by sigma X square into sigma Y square. So this formula we have to remember. Where X is small x minus X bar, Y is small y minus Y bar. Now let us calculate the small x values. So the given problem is like this. Now it is better to have a tabular column to get the values of capital X, capital Y and all. So before that we will have the value of X bar. X bar is the mean value of the given X values. So X bar here is sigma x by n. Number of observations here is n is 7. There are 7 sets of data. Sigma x is the summation of this 1 plus 2, 3, 3 plus 3, 6, 10, 15, 21, 28. So 28 divided by 7, it is 4. The x bar is 4. Y bar is sigma y by n. 9 plus 8, 17, 27, 39, 50, 63, 77. 77 divided by 7, it is 11. Okay? So x bar is 4, y bar is 11. Therefore, capital X is equal to x minus x bar, which is x minus 4. Capital Y is y minus y bar, which is y minus 11. So these things we got now. Now let us have a tabular column. Now we can find out that so we have to find out three things: sigma xy, sigma x squared, sigma y squared. So those three things are required. Now let me have x, then y, then x. These three we will have. So for the given set of data, capital X is x minus 4, capital Y is y minus 11, and of course this is x into y. Yes. Now there are 7 values here. We will calculate the capital X, capital Y value, then we will take the product. 1, 2, 3, 4, 5, 6, 7. Okay, for the first reading, x minus 4, x is 1. So 1 minus 4. This is 1 minus 4, which is minus 3. Then second value is 2 minus 4, which is minus 2. Third value is 3 minus 4, which is minus 1. 4 minus 4, 0. 5 minus 4, 1. 6 minus 4, 2. 7 minus 4. These are the capital X values. So capital Y values are y minus 11. So 9 minus 11, minus 2. 8 minus 11, minus 3. 10 minus 11, minus 1. 12 minus 11, 1. 11 minus 11, 0. 13 minus 11, 2. 14 minus 11. These are capital Y values. Then product of these two, x into y. So minus 3 into minus 2 is 6. Minus 2 into minus 3 is this is also 6. Minus 4 into minus 1, 1. This is 0. This is also 0. This is 2 into 2, 4. This is 3 into 3. So once you get these values, now we will calculate sigma capital X. We need x square. We need x square. We don't want sigma capital X. In this formula, we need these three things: sigma xy, sigma x square, sigma y square. Now next we'll take x square and y square. So have two more rows which give x square and y square. Yes, x square is square of this. So square of minus 3 is minus 3 square is 9, minus 2 square is 4, minus 1 square is 1, 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9. Then y square, square of this. So minus 2 square is 4, minus 3 square is 9, minus 1 square is 1, 1 square is 1, 0, 2 square is 4, 3 square is 9. Now we need these three summations: sigma xy I need, then sigma x square I need, sigma y square I need. So sigma xy is the summation of this entire system. This is sigma xy. We have to add horizontally. This is sigma x square. This is sigma y square. Okay. If we add horizontal sigma x square, 6 plus 6 12, 13, 13 plus 4 17, 17 plus 9 26. Sigma x square 9 plus 4 13, 14, 15, 19, 28. Sigma y square 4, 13, 14, 15, 15 plus 4 19, 19 plus 9 20. So these are the values. Now once you get these values, now you can use this formula to find the correlation coefficient. R is equal to sigma xy divided by sigma x square into sigma y square. So this is sigma xy 26 divided by 28 into 28. So the answer will be 26 divided by 28 divided by 28, 0.033. 0.033. So this is the value of correlation coefficient or Pearson's correlation coefficient. So please note that so the procedure is very simple. So they will give the x and y values. So you need to find x bar and y bar, the mean values of the given x and y values. Then after that you have to take that deviations. These are called as deviations. Deviation of individual value from the mean, x minus x bar, which is taken as capital X, and y minus y bar, which is taken as capital Y. Then you need to calculate the x square and y square, and then sigma xy. Oh, I am sorry. This is root. So this should be root. Root of this and root of this. Please make the correction. Yes. Yes. This is the formula. So here you will get the answer as. Please make the correction. Sigma xy divided by square root of sigma x square into square root of sigma y square. So if you simplify this, you will get 0.90. Yes, this is the correlation coefficient. So you have got R positive, which is positive, and also it is greater than or greater than 0.7, which we can actually say that it is a very good correlation. If R is greater than 0.7, you can say it is very good correlation, and it is positive correlation because as the value of x increases, you can observe here y value also is increasing. So this is the answer. So please make this correction. Sigma xy divided by root of sigma x square into sigma y square. That is the formula to find out the correlation coefficient. So whatever the values of x and y, so you can just use this formula to find out the correlation coefficient.